In the previous video, we had discussed about compounds which have a double or a triple bond, basically alkenes and alkynes. In this video, we are going to be talking about compounds which contain one functional group. So the first rule that we always followed, even if it was a branch chain alkane or an alkene or an alkyne, was selecting the longest chain. And like alkenes and alkynes, the functional group is supposed to be the part of the main chain, irrespective of how long it is. So, in this compound, if we consider 1, 2, 3, 4, and 5 to be the main chain, then our functional group, that is the OH group, is not a part of the main chain. And so, instead, we will be taking in 1, 2, 3, 4 carbon chain. This is because irrespective, like alkenes and alkynes, irrespective of how, even if the chain is not the longest one in the group, we need to select the one which has the functional group in them. So here in this compound you have the alcoholic group. So OH is an alcohol and it's attached to this carbon atom. So this automatically becomes the longest chain and not this one, which is, this is the basic carbon chain which will be selected and its name will be based on this one. Now, of course, like how we numbered the carbon chain for the branch chain alkanes, the substituents over here as well will get the least number. We need to number it in such a way that the substituents has the least number. And not only that, the side chain numbering, the side chains will be named in the same way as well. So before you start looking at various functional groups and how to name them, you need to learn the various functional groups and their suffixes. Here we will be using the suffix to denote the presence of a functional group. And since you only have one functional group, that will be the principal functional group of that particular compound. So that particular compound is the derivative of the basic carbon chain, and that compound has a functional group in that. So before you start naming these compounds, it's better that you have a basic idea about the various functional groups and their prefixes and the suffixes they are denoted by. So in this compound, again, so first let's talk about this. OH is a functional group which is called an alcohol. It is an alcohol and it is denoted in the name as OL. Its suffix is OL. So we know it's an alcohol. This group is an alcohol and it is denoted as an OL. Now we need to number this carbon chain in such a way that this OH gets the least position. Similar to what we did up until now, we'll be doing it both ways. So you have 1, 2 and 3, or it can be the other way round. And we know that 1 is obviously lesser than 3, so this is what is picked. This is wrong. So we know it's 3 carbon chain long, which means it's a pro. Pro is for 3 carbon atoms. And we know at the second position there are 2 methyl groups, and that is denoted as dimethyl. So here this is going to be our prefix. So 2, 2 dimethyl. Okay, so this is the prefix, this is going to be the suffix, this is the word root. Now we'll compile all of them and write the name. So the name of the compound would be 2, 2 dimethyl propan all, or you can write propan 1 all. So generally if it's in the first position, we need not mention the one, but it's better that we do mention it for us to easily denote the position of the alcoholic group. So here we first numbered it, decided on the word root, figured out what the our suffix is, And then we also figure out what our prefix is because we have two methyl groups over here. Next one. So here, if you notice, this carbon is bound to an oxygen, and there's a double bond between these two atoms. So this particular group is called a ketone. Okay, a ketone has a carbon which is bound to the oxygen with a double bond, and on either side of the carbon atom you have an alkyl group present. I'm not talking about the fact, I'm not just saying, okay, there is supposed to be a specific number of carbon atoms. I'm just saying that both sides are, it's bound to a carbon chain. So a ketone is denoted by one, O-N-E, or one basically. So, excuse me. So let's number this carbon chain. 1, 2, 3, 4, 5, 6. So we are including the carbon which is a part of the functional group over here. So this is the from left to right. Then we're going to go back. 1, 2, 3, 4, 5, 6. Now, before we decide on the number, this chain has 6 carbon atoms. So it is hexane. It's a hexane chain. I'm not saying this is the name, I'm just saying this is a hexane chain. Now, here the carbon atom, this functional group, it can either be in the 3rd position or the 4th position, and we'd obviously pick the 3rd position because it's lesser. So, the name of the name of the compound would be hexane, hex, and 3, because it's in the 3rd position, 3-one, hexanone. And to denote the position of the ketone group, it is written as 3. The reason we are writing 3 over here is, if it was in the 2nd, if it was in the 3rd position, we're writing it 3. If it was in the 2nd, we'd write 2. 1, it wouldn't be a ketone, it would be an aldehyde. So it can be 2nd, 3rd, 4th or 5th position, can't be 6th. Technically it can't be the 5th or the 6th also. Actually, it can't be the 4th, 5th or 6th because we changed the numbering. Anyways, so if it's in 3rd or the 2nd position, it would have been, it is a ketone. However, if it was supposed to be in the 1st position, it becomes an aldehyde. So we will be going and looking at that one. So here the functional group is CHO. So I'll expand and write it. Basically here you have a carbon bound to an oxygen, and one side is bound to a hydrogen, the other is bound to a carbon chain. Here in case of a ketone, it was bound to a carbon chain on both sides, but in case of an aldehyde, it has a hydrogen instead of a carbon. So in case of aldehydes, so it's an aldehyde, and its suffix is al or al. Okay, now we need to number the carbon chain. So let's start from the left hand side, that is from the CH3 group which is present. Excuse me. 1, 2, 3 and 4. That's one way of writing the numbers, or we can number it from 3 and 4. Now we know there are 4 carbon atoms in this chain, so its word root is butane. Okay, that's the butane, because you have a suffix, we are writing butane. Next, you have a methyl group. Now, the CHO has to get the least position. So, obviously, this is considered and this is not. The from right to left is not considered. We'll be considering from left to right. So, the aldehyde is in the 1st position and you have a methyl group at the 2nd position. So, 2-methyl. So, again, similar to the alcohol, here, this one is going to be a prefix. This is the suffix and this will be the word root. So the name of the compound is 2-methyl butane 1-al, or you can just write butanal because it's in the 1st position. So the next one, you have a COOH group present over there. So if a COOH group is present, it's called an acid. It's a carboxylic acid. So it is written as COOH, and the left side it's bound to the alkane, the carbon chain. So this group is the is the carboxylic acid, and its suffix is oic acid. Okay, so now we need to number the carbon chain, and we'll always obviously go from right to left, 1 2 3 4, and we'll go from left to right, and then we're going to go from right to left. Okay, so here in this carbon chain, obviously the second from the right to left, it makes more sense because both are methyl as well as the carboxylic acid have a lesser number. So first of all, it's 4 chain long, so butane. Okay, and it has a methyl group at the second position, similar to the above compound. Okay, and its name would be 2-methyl. Okay, it is not visible. So it's going to be 2-methyl butane 1-oic acid, or butanoic acid. Honestly, when it has come to acids, I've always been confused about the fact that if we should include this carbon atom or not. For some reason, I've always had that. The way I started remembering the fact that we need to include the COOH as the part of the main chain was the fact that ethanoic acid or acetic acid's formula is CH3COOH. And here you have 2 carbons and it's ethanoic acid, then obviously we need to include the carbon atom of the COOH group. Now the last compound, COOC2H5. Now this is a unique compound called an ester. An ester consists of, it's basically a derivative, it's considered a derivative of the carboxylic acid, and you'll be learning in detail about various functional groups and the reactions of all of them in grade 12. But here an ester consists of COO, and instead of a H like carboxylic acid, it is bound to another alkane or a carbon chain, and it is denoted, its name is given as O8 alkyl O8. Okay, so this I'll again talk about once again. First, let's number the carbon chain. So 1, 2, 3 or 4, and you have it backwards as 1, 2, 3 and 4. So obviously we will be selecting this way, so it's in the first position, we need not worry. And we know C2H5, this is an ethyl group. So here this group is an ethyl group. So the alkyl group which is attached to the ester is an ethyl group. Okay, now it is 4 carbon long, okay, which means but. Okay, now we need to write the alkyl group ethyl butan O8. So ethyl butanoate, this is the name of the ester. So in between alkyl and O8, the name of the word root will come in. So with that we finish the compounds which contain one functional group. In this case, we will be denoting the functional group using a suffix. So for you to understand, or for you to basically name it, if you find it easy, first we are identifying the functional group, then we'll be identifying the longest chain. And remember, even if the chain is not the longest, if it consists of the functional group, that is what is considered, like we looked at this example. When the various substituents of the alkyl chain present, then they are named similar to how we named our branch chain alkanes. And so we'll be writing in the prefixes, and then we are just combining all of them to get the name of the compound. Nomenclature is something that you need to, you'll be able to write the name of the compounds only with a lot of practice, and practice is key. But for that to happen, you need to understand the basic idea behind how to name a compound. With that, we finish compounds containing one functional group. In the next video, we will be discussing about compounds having a functional group, a multiple bond, as well as a side chain. As well as we'll be discussing about compounds which have more than one functional group. Do check it out.